Let's start now. And today is relativity intensive class 03 about geodesic equations and use of Lagrangian to find the geodesic equations. So can you guys send me a message to tell me whether you can hear my voice? Yeah, thank you very much. And I will adopt the format of exercise class. So first let you do the part A. I give you 10 minutes, okay? And then I will go through step by step slowly to lead you to about the answer. So you have 10 minutes to do it. All right, time's up for the part A. So basically, this exercise class is focused on the part C, using Lagrangian to calculate the geodesic equation and the crystal symbol. So I think the previous two intensive classes are useful for you to calculate the crystal symbols. So I assumed you have already very familiar to do the crystal symbol. So let me go through it faster. So basically, the question is consider two-dimensional surface embedded in a flat 3D Cartesian space. So we just only need to consider the 2D surface with 2 degrees of freedom. One is R, and then is phi. So and the questions is has given the metric tensor, and you just use the metric tensor to go through the crystal symbol, which is the classical way that Johnny has already talked to you guys in the lecture. And how to calculate crystal symbol, we adopt this equation, and which composed by derivatives of the metric and also the inverse of metric. And what is the inverse of our metric tensor? So basically, for our tensor, we have write down the normal form, and then the non-diagonal term is equal to 0. So basically, for the inverse of the metric is just basically if the diagonal component 1/. Right. And sometimes I have seen some students they have done some they assumes all the inverse of the metric is just 1/, the component of diagonal components. This is not in general is not true, because when there are some non-diagonal term in the metric, like curl backhold metric, you have to do find adjoint, and then find the inverse, which you have, I assume you have learned in your high school, M1, M2, and then you can find the non-isotropic metric inverse of a metric, and this case is very easy. And then for crystal symbol, let us to consider the first component 1/1, which is ORO. I would write 1/1 instead of RO, because here we using the notation x1, x2, and then which would be equal to alpha 1 G alpha 1, and derivatives with respect to the first quadrant 1, and posit 1 alpha. So as we know, all the non-diagonal terms vanished, and we only have the G11 is non-zero, and then we know that it's just basically G11 2 times this guys, and and then the final one is just the same, and all right, and the final answer is very easy. It would be only derivatives of G11 component with respect to the RO. And then we know the inverse metric G11 is the 1/(1 plus f prime square, and the derivatives of the G11 is our derivatives 1 plus f prime square. So after a simple calculation, okay, I simplify this, the notation. it would be like this. Okay. So, and then the second component, we want to calculate like 1, 1, 2. And it would be 1/2, of course, G alpha 1 and the G alpha 1, 2 plus G alpha 2, 1 minus G 1, 2 derivatives of the alpha. Yeah, and again, the non-diagonal term are finished, and we only have left 1, 1 times the G 1, 1, 2 term, and all of that 1, 2, 1, 1, 2, and 1, 2, 1 minus G1, 2 alpha, which two guys would be 0. And then the G11 is just basically has arrow in dependency. It does not have any phi dependency, so this guy would be equal 0. And then you know the crystal symbol would be symmetric. So, and now we have 6 total components of the crystal symbol. We have calculated 3 of them, and we calculate the second one, the crystal 211, which is the phi RR, in case you get lost. So it would be equal to 1/2 G 22 G21 with respect to derivative with respect to the R minus the G11 prime 2. And after that, you can find just like the last answer, okay, it would be 0, and then this guy would be no independent dependency of the phi, and then it would be turns out 0. Okay. And 1, 2, 2 would be 1/2 G11 times 2 times G21 prime 2 minus the G22 prime 1. Okay. And then this would be eliminated. Okay, the G22 component has dependency of R, so it would be non-zero, and it would be 1/2, and the G11 inverse measure of G11 is 1/1 plus the F prime square, and time stir minus R derivatives of the G22, which is the R square. Finally, it would come out something like that. Make sure your answer is correct. And I think I should highlight for the non-zero component for you guys. Yeah, and then the final one is 2, 1, 2. Go to 2, 2, 1. Okay. And what is this? It's just basically 1/2, 2, 2. Okay, I just do the same mathematics. 1/2 times this guy would be the 1/R square, and times the what's left. These 2 would be 0, and then it would be R square derivatives with respect to R, and finally it would be you can find it. It would be 1/r. And then 2, is do the same thing. Okay. By inspection, it would be proportional to the G22. It's easy to find. All the component would be 2. So it must be 0. So it is all the crystal symbol for this problem. And I hope you guys correct. And any question, please feel free to ask me now. So part A is very easy. And part B, you have 2 minutes to try it by yourself, and then I will check the answer. So any question, you can feel free to open your mic, ask. If you think you have already finished the part A, B, they are very easy. And you can try the part C. You can just want to look for the second approach. It will be very subtle that you just need so much time than you expected to calculate the crystal symbol one by one, even we are under a 2D coordinate. Okay, maybe you imagine 3D, 4D coordinates. You may really consider how long you need to take to calculate all the crystal symbol when you are in during in an exam. So you have to consider by yourself. So just think now if you have time. So after 2 minutes, I will show you the part B answer. Okay, time's up. And part B, just give the expressions for the geodesic equation. Part B, and for the geodesic equation, you have something like this, right? Alpha beta dot equals 0.
and x dot would be, yeah. So what is the answer? You just try to plug in all the things like when mu equal to r and mu equal to phi. So let's talk about the first case when mu equal to r, and it would be the x dot dot r, which is the r dot dot. You can directly write it to be this form, and plus the crystal symbol r and alpha beta times the x dot alpha x dot beta equals 0. All right. And what is the non-zero component left for the crystal symbol? As we have talked above, and we don't have any 1, 1, 2, and equal. This guy would be 0, right? And then we can use it. We have 1, 1, 1, and 1, 2, 2 will be non-zero, and the non-zero term will have a Einstein summation, and will be big gamma r. It will be 1 and 1, 1 times the x dot 1. X dot 1. This 2 would be the r dot, and plus the big gamma. Okay, here would be the r. I write it down as 1, and plus the 2, 2, because it is not a second non-zero term. And then you have to contract alpha and beta. The x dot would be the 2. X dot would be the 2 equals 0. And the final answer for the mu equal to r case, the geodesic equation would be, we plug in the gamma 1, 1, 1. It will be something like this that we have just calculated, and the x dot 1 would be the r dot square. Okay, because it has 2 x dot 1, and plus the big gamma 1, 2, 2. It would be the minus r over 1 plus f prime square. And the x dot 2 is just basically the phi component dot d phi d lambda. Okay, and by simplifying all this thing, you can get the geodesic equation of r, which is the equation of motion. Of r in this problem under this coordinate plane. All right, and then the mu, when the mu equal to phi, what is the case when mu equal to phi, which the coordinate would be, the mu is 2 dot dot, right, plus the crystal symbol 2 alpha beta times the x dot alpha x dot beta equals 0, right? And what do we have? The non-zero component of the crystal symbol with the mu equal to 2. So we only have big gamma 2, 1, 2, and also it is symmetric tensor, and it has these 2 terms. As I have marked some midterm, some students, they only consider, they think they if the 1, 2 component is non-zero, that these two components are non-zero, that they only write down one crystal symbol times the x dot and x dot 2, x dot 1 and x dot 2, which is incorrect. That because the summation, okay, you have include plus when the alpha beta flip the 1 2 number, it will be big gamma 2 to 1 times the x dot 2 x dot 1 equals 0. All right, and then so you know it has two terms. Sometimes different students just ignore the later term, or they just ignore one of them. Okay, what is the answer of this? The x dot dot 2 is the phi dot dot plus the gamma 212. It will be the 1 over r. All right, and times the r dot x1 and times the phi dot. And the second term 221, it will be the same as the 212 equal to 1 over r and times the phi dot and times r dot. All right, and the final answer would be 2 over r. Yep, here is the equation of motion when the mu equal to phi. And that is all of the answer for part AB. And then part C, I will spend most of the time to do it. So could you guys think of another approach, another method would be much faster than this fully mathematical approach to calculate crystal symbols and the geodesic equations? The bracket, no. Any suggestion? Any suggestion? So now, basically, for the part AB, okay, part AB would be just a mathematical approach, like you do the differential geometry, and Johnny wants to strengthen your mathematical basis, fundamental skills. That he has chosen the first course, that book, which focus on the mathematical trick. And then you guys just learned all the ways about the Riemann geometry, differential geometry, something like that, and use a metric approach to calculate all the crystal symbol, right? And actually, if we don't want mathematical approach, we can use physical approach to argue, to find a crystal symbol. How? So basically, what is a geodesic equation for a given coordinate? Can you guys just give it a try, or yeah? What is the meaning of the geodesic equation? Yeah, equation of motion, and then what kind of equation of motion? Do we have an external force? Did we add any low force? And why? And why it will have some motion? Why it moves? Yeah, curvature of space-time. Very good. And sometimes I found out some students they don't know what is geodesic equation. And geodesic means when I give you a general coordinate, the geodesic equation, we put a particle like massless or massive particle, it would walk the shortest distance, okay, from point to point. Okay, this is the meaning when you comes out. Yeah, maybe you have learned in your lecture notes or some YouTube video before. And basically, the shorter distance, you have know that in the fat space, Euclidean 3D space, it would be a straight line, right? And sometimes let me remind me, and I have heard that from Johnny before when I took this class, and it reminds me, okay, classical mechanics 1. What you have learned classical mechanics 1, which is Lagrangian, right? There's an example. I given you a Euclidean geometry, and then you find the shorter distance between 2 points, it would be a straight line. Why we can use Lagrangian to do this with just only kinetic energy and potential energy? Because what we have learned before the general relativity, yeah, we are just using the Euclidean space. So you assume all the things would be straight line for the shorter distance, but it is not in general relativity. Like the angle equal 180, like for a triangle. But in some due to some curvature in some general coordinate curved space-time, the sum of the angle of the triangle, it would not equal to 180 degree. So why I'm telling you about the Lagrangian? Because geodesic equation is just basically the shorter distance from point to point under this coordinate system, right? Under this metric, right? So of course we can make use of the Lagrangian without any potential. Okay, why? Because it's no force, a free particle. So now I give you some times, like Part C. Okay, use the Lagrangian approach. Now you have a Lagrangian and Euler Lagrange equation. Oh crap. And the Lagrangian is given to be 1/2 times the G mu nu times the x dot nu. So you can try now. I give you 10 minutes and then you kind of to make use of this Euler-Lagrange equation and then to find the geodesic equation. And then once you found the geodesic equation, and you can compare it to this guy, right? And then you can easy to figure out the crystal symbol. So you may not understand at this moment, but yeah, I have to ensure you have to learn during this intensive class.
All right, time's up. And let me answer your question first. Someone asked me whether this Lagrangian is invariant. So I told you have to check why. Could you guys answer me what is the invariant length? Whatever I give you a general metric. Invariant length means line element. Like that element could be agreed by all of us. Hello? No one can answer? Okay. It appears in the textbook actually. And okay, how you define so-called length when I give you a general metric? Not a coordinate length. It's an actually line element of the metric, right? What's this? Which is invariant for all of the coordinates. Yeah, exactly. Thank you, Hong Hong. And for the line element, you have to write down the ds square, right? It would be G alpha beta, something like this. Okay. And okay, you ask us, oh, ds square, right? Why don't you just directly tell us it is ds square? So when take the absolute value of this, okay, we want to measure a length which is invariant for all of the frame with L. Okay, let's label L. Okay, along any curves. Okay, along any curve with deviated dx alpha and dx beta, it would be something like this, right? Right. Which is exactly appear in your first course textbook, 6.6. Okay, and you know this length would be invariant, right? And this guy, what is the Lagrangian I give you? It would be the Lagrangian with respect derivatives with respect to the infinitesimal dx alpha and dx beta with respect to the alpha, right? So it must be the invariant. Okay, this is the first thing. And then, so let's start to check out the answer. And finally, you may agree that is your first times to use this method to do it by your own is very precious. You will agree with me. So, what is the method? Let's write down the Lagrangian, right? Equal to 1 over 2 times G mu nu x dot mu times x dot nu. And then we plug in, we first calculate the Lagrangian, Euler-Lagrange equation, which you have already learned in year 3, classical mechanics. Okay, I have to remind all the metric component. All right. Okay, let me write it down. For the metric component be 1 plus f squared
0, 0 r square, right? And then one Lagrangian of the one x mu would be the 1 of 2 g mu nu, right? And we just first we calculate the mu equal to r, okay? Just like what we did in the previous question, we separate two cases for mu equal to r and mu equal to phi. And then mu equal to r would be, or we write it, partial derivatives with respect to the r, right? And if we g r and g r plus g phi phi times the g phi dot something like this, y. And the partial derivatives of the r with respect to r. All right, and you know, as you have calculated before, in some Euclidean 3D space, like if you only have a ke term, okay, equal to v square, something like this, right? 1 over 2 m v square. And then your Lagrangian only have this term. You calculate, okay, let's see the r dot using the cylindrical coordinate, r square phi square, something like this, right, in the Newtonian mechanics. And then you calculate all the partial derivatives with respect to the x mu if the case without any potential energy. It have to be, okay, I don't consider this term, like something like this, okay, like a linear example, dx dt square. It has to be 0, right? However, for some curvilinear coordinate or some arbitrary coordinate, in this case, you may find out our GRR would be depend to the R, and then the answer is x dot R. Okay, I write it to be R dot square time the GRR f prime 2 times the f prime and times the f prime prime, right? And second term would be, if I make some typo, please tell me immediately. Yeah, this technique is not oddly familiar. Yeah, actually, I you know, many students did not go through the exercise class or watch the video. You know, this technique have also taught by Alan, another TA. Yeah, it appears, and maybe he used a Schwarzschild metric to do that, and I just repeated in this intensive class, just like the intensive class 01 and 02. Right, they just repeat all the techniques, so don't care about it. If you want to make do one more example, you can go to the exercise class 6. So for the second term, g phi phi would be also dependent on the r square. It would be 2r times the phi dot square. All right. And then we have to calculate the Lagrangian derivative with respect to the derivatives of the x mu, which is the okay. What's the answer? So I just write it down. It's very simple mathematics. Okay, when you substitute the mu equal to r, okay, we only have two diagonal term, right? The Lagrangian, as we expand it, I use red pen, okay, would be r dot square plus ng5 phi dot square, right? And then we just this guy, the first term, it would be times 2 GR dot, okay. All right. Finally, it would become a 1 plus f prime square times r dot dot, okay, because of the one more derivatives with respect to lambda. All right, now we have a Euler Lagrange equation. You know I'm doing very, very slow. Make sure you guys can follow me. Okay, and then we write down all of it minus, okay, equal to the dot f plus r dot phi dot square. All right. And what we want is going to compare it with the geodesic equation, right? And then find the crystal symbol. So we just want to the whole equation divided by the bracket 1 plus f prime square here with the geodesic equation, and this geodesic equation is exactly what I have done in part B, okay, right? Any disagreement? So now you can calculate the crystal symbol that reach compared to the red written geodesic equation. R, which is the R equal to beta equal to R term. And here we substitute the mu equal to R. So this guy would be the gamma R, which is the 111. All right. Let's see. Doing is correct. No. Okay. No problem. It here would be a minus sign. I did some typo on the side. I don't know why. Oh my god. But why? Plus. So what? Minus sign, come on. Okay, fine. All right. It would be minus alpha squared. Whoa, where is the minus I? Oh my god. Yeah, maybe I make some typo. Sorry about that. Yeah, I currently cannot find the typo. Sorry. You guys, maybe if you find it, please tell me. And yeah, I make some typo when calculating the geodesic equation. And here would be the plus sign. Yeah, that makes sense to the previous solution. And then you can calculate that would be the crystal symbol is equal to this guy. Okay. Sorry about that. And this guy would be the alpha equal to beta equal to phi. Okay. Which the crystal symbol it would be the gamma r phi, and then equal to minus r 1 plus f prime square. Yep. And then you can find all the crystal symbol with mu equal to r. Okay. All the crystal symbol of mu equal to r. And then the other one would be 0. 0 for other case. Okay. And then we plug in the mu equal to phi. Okay. The mu equal to phi, and then we use this Euler-Lagrange equation. Okay, that's to calculate the derivatives with respect to the phi. So actually, there's no any phi dependency, right, for the Lagrangian equation. Okay, and then calculate the x dot phi and also derivatives with respect to lambda. It will be equal to the g mu nu. Only have this term left. G phi phi times the x dot phi times 2, right? And then finally, you have a derivatives of with respect to lambda, and it would be G phi phi. What is the G phi phi? It will be R square. Okay. God. G. Okay. It will be the R square and X phi dot, right? Derivatives with respect to lambda. And by product rule, the alpha can vary with respect to the lambda. And something come out. Okay. N plus the R square phi dot dot. Okay. And finally, this guy will be equal to 0 as the partial derivative with respect to x phi equals 0. Finally, can just massage the equation. It will become this, and which is exactly, this time there's no any accident. Sorry about that. And yeah, so for mu equal to phi cases, the geodesic equation is easy to come out. And compared to the geodesic equation, x phi dot dot plus gamma phi alpha beta x dot alpha x dot beta equals 0. So what is the crystal symbol? You can easily find the crystal symbol of phi. Okay, we only have this term, right? The phi dot r dot. Okay, which the alpha equal to phi and r beta equal to r. And also, it will be the same value for alpha equal to r and beta equal to phi. That's why the 2 automatically comes out. So here would be 2 terms plus 1 r dot phi plus 1 r phi dot r dot is 0. And then you know that the phi r phi equal to gamma phi r equal to 1 over r. And then the other with 0. Okay. So what I have shown you guys just the easiest way to deal with. Maybe you still disagree. Okay, or well, okay, this is very tough. I'm not that familiar with the Lagrangian. But one thing I have to tell you, last 2 years, the exam of the 4460, Johnny have to examine the students to write down the geodesic equation, which is the equation of motion. Okay, like what he did, just give a 3D space. Okay, and there's no marks to calculate the crystal symbol and how you calculate the geodesic equation. So the question would not be like the midterm. Please calculate the crystal symbol. Blah blah blah. Like he gives you a GMT. But this kind of question would not be up here in the exam in last year. And instead, he just asks you to write down the equation of motion directly, which is geodesic equation, by giving you the GMT. And then what can you do? The fastest way. If you, according to your previous knowledge, you have to calculate all the crystal symbol, but the marking scheme would not count the marks when you calculate the crystal symbol. Okay, and then after you find all the crystal symbol, like
3D space, you just spend half an hour to do all of it, and then you just get 2 marks by getting the geodesic equation. Okay, something like that. Okay, another advantage, apart from the efficiency of this way, the other advantage is when you study the physics, the equation of motion, like I give you a Schwarzschild black hole, okay, you have to calculate some conserved variables, like conserve the quantity, okay? Like I give you a Schwarzschild metric. Schwarzschild metric is just something like this, right? Okay. And the later course, we may focus on how to make use of the Schwarzschild black hole, and then to calculate some geodesic equation. Apart from using Lagrangian of this, okay, you have to learn one more thing about the differences between the massive particle and the massless particle. You have to make use of this, what we call is kinematic equation, okay, and which is for massive particle and equal to 0 for massless particle. They will have a little bit difference when it attracted by a point mass, like your sun, and then for massive particle, it would generate some path like the Mercury orbiting around the sun, something like that. Okay. So it is very important to use Lagrangian formula to derive the equation of motion. Okay, and it's very fast. So any question you may ask me right now. And yeah, another thing, like some kinds of question, Johnny maybe ask you like the radial info. Okay, maybe just giving a general metric, like here. Okay, I take Schwarzschild black hole as an example. Okay, and how you calculate the radial info? Let's say it gives you a initial condition. Okay, like dt d phi d theta equals 0, and for observer, directly radial info to a black hole. What is the coordinate frame outside the gravity, like we observe it in the Earth? How we observe this guy or this ball attracted by the black hole? What is the equation of motion, and what is the equation of motion, or what would be observed by this point of mass in its perspective, which are different. Okay, so you have to learn this Lagrangian formula. So, any question about it? Yeah, I don't know which step I have make some typo to calculate the sign. Maybe I will show you in the answer, and yeah, I will fix it up later. So any questions? Yeah, we may end this class very early because I think if you
make sure you understood all the geodesic equation, Riemann geometry, and crystal symbol. You can easily deal with the gravitational wave and black hole dynamics, something like this. If you know question, you can leave now. Yeah, this is the end of the intensive class 3 today. Okay, one more thing. So Winkit No is asking, like we given a source of potential, there is general approach, blah blah blah. Okay, why the Lagrangian? The first question is why the Lagrangian does not have any PE potential term. Oh, sorry, minus. We only have, okay, something like this. The kinetic energy term, and then the ball will fall into the black hole by assuming P equals 0. Why? Because it is the intrinsic property of general relativity, right? Because the gravity makes the space-time curved, and then the ball would follow the geodesic equation to the point of the mass laterally without any potential. So if you talk about potential or source, okay, in GR course, it only have 3 potential when we want to add into the Lagrangian, like the electromagnetic potential, okay, but we do not consider, and the weak force and the strong force, which is all the particle physics. And so please forget what PE equal to minus GM M over RO in this course. What is the gravity? Gravity is not a force. It's the particle laterally fall in the black hole, okay? Because it should be. Yes, it is the nature property. So after this class, you may learn the true meaning of the geodesic equation. Like I give you a general metric. So any question? Actually, any question other from this intensive class you can ask.